Hi everyone, I'm Giovanni and I will present the design part of Smart Museum. According to official data from the Ministry of Education, Sapienza had over 10,000 foreign students in 2018 from a variety of countries. Most of the museum visitors are students. The main idea is to make the museum more interactive for visitors and more functional for the curator. From the visitor's point of view, the position of the visitors will be recognized through the beacons. Therefore, on the application, the visitors will see the description of the artworks through text, audio, and video descriptions. If the visitor is a foreigner, he will have the opportunity to change the language at any time. There will be personalized paths inside the museum. Here we see Anand, who is a foreign student who knows Italian and English not very well. He prefers his native language and with Smart Museum he will have the opportunity to visit the Museum of Sapienza. The curator will have the opportunity to observe the traffic of each room, optimize the position of the artwork so that there are no overcrowding, and use the tracking data for further analysis such as customizing the pets inside the museum. She will be also able to monitor the climatic condition inside each room. Here we see Gabriella, curator of the museum, using the application to monitor the weather condition of each room and rearrange the position of the artworks, obtaining a more balanced traffic between the rooms. Now we will see a simulation of the prototype. The application refers to the first prototype and asks us to activate Bluetooth. In the upper right corner you can select the language you want. Through the beacons, the app will recognize the room we are in and show us all the artworks present. In the main section, we find Choose Path, which allows us to choose the custom path. Once the path is chosen, the visitors will have to follow the instruction and the game will be done. From the feedback of some users, it emerged that they would like to use the application even without Bluetooth. So we added to the prototype the manual section where you can choose the rooms. Possible future developments could be the insertion of augmented reality, the use of QR codes, or the sharing of audio description to groups, replacing the radio model used in many museums.
Hello everyone, I am Nicola and I'm going to show you the architecture of our Smart Museum project. The core component of the project is a Nucleo board that will implement Bluetooth beacon for user indoor tracking and indoor microclimate monitoring to preserve artworks. The microservice architecture allows us to deploy and scale independent lead services. We can replicate some services to be always viable, and we can also integrate external services, providing always a uniform access point with the API. Giovanni already spoke about clients app, so I will skip the description. Here there is an overview of how all the components interact. The Nucleo board uses both LoRaWAN and Bluetooth Low Energy. The middleware communicates with the Think network through MQTT, and all the other components will communicate using HTTP. To evaluate the project, we have used all those parameters in detail. We have assumed no development costs since the community works for free or for extra point to the IoT course. Due to this particular period, microclimate monitoring with LoRa is simulated on testbed. Beacons are simulated locally with a personal computer. Software is tested as usual. We are constrained to use Nucleo board, so we have chosen only compatible extensions to support the project goals. To estimate cloud storage costs, we have defined a data model. We pick up MongoDB as a technology, and according to the internal document format, we have roughly estimated the total storage required. We conclude that AWS and Azure are the most competitive solution, and the cheaper solution is hybrid. Maybe InfoSapienza can host our application without any additional cost, so it might be advantageous. We considered also an experimental solution, since the Maker community is experimenting a lot with clusters made on Raspberry Pi that have very low power consumption with respect to a bare metal server. Thank you for the attention. We are here for questions.